Dear students, welcome to the e-learning. Hello, I am Navdeep, working as PGTIP in Cambridge International School, the SUA. Students, in this series of lectures, today we will have one more lecture on operations on arrays. So before we go into the details of the session, first of all, that you have to take care of your health and also help your family members in day-to-day tasks. So now I start the lecture. So till date we have covered a number of topics on arrays. So today we will apply the operation on arrays, splitting the arrays, and then we will apply different statistical operations on the arrays. So before going into the details of today's topic, just have a look at the topics that we have covered till date. Introduction to NumPy, what is indexing, slicing to cut a array into smaller parts, applying different arithmetical operations like addition, multiplication, division, remainder, operation on arrays, and then is transpose. What is transpose? Is converting rows into columns. Then we did the sorting in the ascending order, and we can go for descending order of the arranging the elements, concatenating, that is combining two arrays, and finally reshaping. So NumPy, we have already gone that it stands for numerical Python. The NumPy array is officially called the ND array, n-dimensional array, but it is commonly known as arrays. So there are different built-in routines or functions available in NumPy for creating, manipulating, and transforming the arrays. Indexing, we already know that indexing in one-dimensional array, indexing in two-dimensional array. So indexing help us in accessing the elements, selecting the element. Clear? And by default, the position starts from 0. That's why this is also called the zero position based arrays. Then is slicing. And slicing is, what is this? This is a sub part or part of the array. So we can pick up a part of the array from the bigger array. So that is what we meant by the term slicing. Here we have a start value and the end value, from where the slice should start and where it should end. Then we covered the arithmetic operations like how to apply the addition on two arrays, and how to apply multiplication, division, remainder. So different arithmetic operations on the arrays. Then the transpose is another important operations on matrices, converting rows into columns and columns into rows. Then we did the sorting, is to arrange the elements of an array in the particular order, like in the ascending order or in the descending order. Concatenating the arrays. So concatenating means that we can join two or more arrays to avoid any mismatch in the in these operations. So what we need to do that if we are doing the operation row wise, so then the number of rows of the two matrices should match. If we are applying the operation column wise, so the number of operations of two or more arrays must match. So there should be a matching between the number of rows or number of columns by which we are applying the operations. So this is the only condition that we need to meet while concatenating the arrays. And in the earlier one, in the addition and subtraction, the order should match. Reshaping the arrays. So reshaping, that we can modify the shape of an array using the reshape function. So reshaping cannot be used to change the number of elements. So we cannot change the existing number of elements. We can just change the, like we have 12 elements, so we can make a matrix of 3 by 4 also, and 2 by 6 also, and different orders we can make, but we cannot increase or decrease the number of elements present in a array. So student, focusing on the today's topic, that is splitting the arrays. So this is very important topic, splitting the arrays. That we can split an array into sub arrays. So we can split an array into two or more sub arrays with the numpy.split function. So this is the numpy method named split. So it splits an array along with the specified axis, means row wise or column wise. We can either specify the sequence of index values where an array is to be split, or we can specify an integer n. So that we will look in the example also. That indicates that the number of equal parts in which the array is to be split. As parameters to the numpy function, by default numpy splits along the axis is equal to 0. So we can split an matrix along the axis is equal to 1, means row wise or column wise, depending upon the requirement. So now we'll take an example that will give you a better view that how we can split the matrix. Clear? So for better understanding, now we will move to the Jupyter notebook. So on the Jupyter notebook, students, our number one task is to first is import numpy as p, because we are going to use the methods from numpy. So I name the array as array4 is equal to np dot array method, then these square brackets for row wise entry. First element is 10, then is -7, then is 0, then 20. So it has 4 columns. Go to the second row. First element is -5, then 1, then 200, then let's say 40. Then move to the enter the third row. In third row we have 30, then 1, then -1, then 4, and move to the next row, fourth row, 1, 2, 0, and 0, 4. Clear? And then finally with the last row, 0, 1, 0, 2. So these are the elements of the last row. And to just print the array4, go to this run option, and this star means that my program is in the running state. So you will find the output. So this is our standard matrix on which we will apply now the split operation. So this consists of 5 rows and 4 columns. Clear? So student, this is the matrix we have. Now we are going to split it. Clear? So splitting row wise and column wise. So first we apply the, let's say, row wise. By default, start with the row wise. Now see which operation I am going to apply here. I am going to apply the operation row wise. So let's say I divide into 3 parts with Let's say first part I name it as first, second part I name it as second, third part I name it as third, is equal to npi numpy's function split. First parameter is mention the array, and the second parameter is what sort of partitions we require. So this 1 and 3 means that the first is I want to split the row 1, then up to row 3, and then the third part is the basically my remaining array. So students, here is first means that first part will be assigned to first variable, the second part of these two rows will be assigned to the second variable, and the remaining part will be applied to this third part, the third variable. So basically this is we have done the three partitions. So you run this one. So now you can see that what the first contains. So first contains the first row. Similarly, when I write the second, run this one. So you see the second is basically from second, it contains seconds and third row. Clear? From where? From this original matrix. First variable contains the first row, second variable contains the second and the third row, and you see the what the third variable contains. Third variable contains the remaining part of the matrix. So here what is the important thing to learn here is that by default that I have not mentioned the axis. So by default the operation is performed on the row wise. Similarly, we can go and apply the operation on the column wise also. Now students, that we are going to perform the splitting of arrays, and the operation is now the column wise. Now see how this operation, the same operation on the same matrix. Clear? What is the matrix we have? Basically you can see here the matrix. This is our matrix, and now I am going to apply the splitting of the arrays column wise. Now what is the operation is, let's say my first variable is first C. C is, you can say, for column, second C, and third C. Clear? So the operation was numpy dot split function. The first parameter is our array, second parameter is how we are going to partition. So partition on the basis of splitting on the basis of first row, then we have first column, then second column, and finally the remaining part. And to apply the operation column wise, we have to pass the third parameter axis is equal to 1, because by default the axis is 0, because the operation is on by default is on row wise. So if we have to apply the operation column wise, we will have to explicitly mention this parameter, that is axis is equal to 1. Run this one. So the statement is run successfully. Now you can see that what the first C variable contains. First C variable, students, contains the first column, because we have seen here mentioned in the splitting part first, then the second. So the second, after a split, you see what is this second variable contains second C. Second C variable contains, run this one. So you see the second variable contains the second row. Clear? And the third variable contains the remaining part of the matrix. So you can see third C, and just go to this run option. So now the third C contains the last two columns. Clear? So students, this is how we have basically applied the split operation on the arrays, row wise and column wise. So students, next see that if we have to split this matrix column wise into two equal parts. Clear? So what will be the my statement? Let's say first half comma second half is equal to numpy dot not array but split, and the first parameter is array 4 that we want to split into two equal parts and along column wise. For that we have to say x is equal to 1. So now you run this option and now you can see what the first half variable contains. Run, and you see the first half contains the first two columns, and similarly you can see the second half variable. What does it contains? Just run this one and you can see the rest of the two columns here. So we can apply the different combinations for the split operation and we can see the results. So I hope that students you are now familiar with the split operation. Practice this and execute this one. Now students, moving to the statistical operation. So you are familiar with the statistical operation, mean, median, mode. So this sort of operations that we will apply on arrays will fall under the statistical operation in NumPy. So NumPy provides the functions to perform useful statistical operation on arrays. So we'll have a look at what are these operations that we are going to apply today. So the first one is maximum. So maximum function finds the maximum element from the array. So we can apply this operation row wise and column wise also to find the biggest element. Similar, the next is the minimum. Minimum function is to find the minimum element. Clear? Then is the sum function. So we can find the sum function. We can find the sum of the elements of the array. So that is how we apply this aggregation operation sum. Then we have mean function, that is to find the average of elements. Like let's say in a class of, let's say, that contains 20 students, 30 students, we want to find the average height of the students. So that is what we meant by a mean or average. Then is the standard deviation. So this is one more important statistical operation. So standard deviation function is used to find the standard deviation of the array of elements. What it actually is. So a quantity expressing by how much the member of a group differ from the mean value of the group. So students, how much the elements are basically getting varied from the average average of that very group. So that number is given by the standard deviation. So hope you understood what is the standard deviation is. So now I move to the Jupyter notebook for the application of these functions. So for the application of different statistical functions, first of all students, we create the array. So let's say my array is a one-dimensional array, numpy.array, that I create with this method. So let's say first element is 1, then 0, then 2, then -3, then 6, then 8, then 4, then 7. So let's say we assume these values for array A. Then I create another array B, that is basically a two-dimensional array. Clear? So with the first row containing 3 and 6, and the second row contains 4 and 2. So to have a look at these, so you can see here array A, this one contains this one-dimensional array, and similarly array B, what does it contains? This is a two-dimensional matrix, clear, having 2 rows and 2 columns. Now I apply the first operation is the array a dot max to find the maximum in the array A. So you run this one, so you get 8 because 8 is the maximum value. Similarly, students, you want to find the minimum of this one. So you just run this one from the array. The minimum element is -3. So let's assume that now we are going to work on matrix B with the minimum function. So you run this one. So you get the minimum is 2. So it will find the minimum among all the elements. Similarly, to find the maximum in the matrix B, you run this one and you get that 6 is maximum. Very simple, this one. If I supply here a parameter x is equal to 1, now you see here it will find the maximum element, clear, but it is column wise. And if I apply here x is equal to 0, so it will find the maximum element, but see now the maximum element is row wise, clear. See here x is equal to 1, so it will find the maximum elements, clear. And similarly we have x is equal to 0, so you run this one. This is the row wise operation. Row wise is toward this one, column wise operation is toward this side, clear. So you have to remember that where the axis 1 works and axis 0 works. Similarly, the same operation we can keep on work with the minimum function also. You run this one, so x is equal to 1 is this wise, so this wise means that minimum in this is 3 and minimum in this is 2. Similarly, minimum in or this row wise, so row wise means like this and this is having minimum is 3 and this time minimum is 2, clear. So now students will move to the next function is, now we work with the sum function. So let's say first array A, and I apply the sum function to find the sum of all the elements, so all the elements of this array, clear. So the sum is 25. Similarly, to find the sum of all the elements of this matrix, so this will be array B with sum function. So you run this one, so you will find the sum of this all the elements. So similarly we can apply the find the sum row wise and column wise, student. So if I supply here x is equal to 1, run this one, so you see here that the sum here is 9 and 6. So this is the operation we have applied with x is 1, so this giving me the result row wise, clear. This row containing 9 and this row containing element 6. Similarly, if we have to print the result along column wise sum, so you just run this one, so column wise sum is this 7 and 8. So this is how we can apply the sum operation on different axes. Now we move to the next function, that is array A dot mean, so the average of the this first array A, so the mean is 3.12. Similarly, we can find the array B dot mean, and you run this one, so this is 3.75. Now along the axis, if I say axis is equal to 0, So you run this one. So how you will get the axis meaning here? So first you have a look at the array B also. You run this one. So you see here the sum is, we have got the average 3.5 of this one and 4 average this way. Similarly, if we want to apply axis is equal to 1, so you will see when you run this one, so the average is now 4.5 in this row wise and like this. Clear? But it is actually the axis is for column basically, because we are considering here combining both of the columns, column 1 and column 2. Clear? So there is a basically mismatch and a bit confusion in the language. Clear? So the another column wise operation is like this. Clear? So you see here its average is 4 and 2, the average is 3. Clear? So students, you have to get familiar with the language what the x is 0 and 1 means. Clear? Just you need to take care as we are taking care of index value, like it starts from 0. So sometimes it gives a confusion, but with a little bit practice you will become familiar with this one. So now we have to start our final function, that is standard deviation. Array a dot std stands for standard deviation. Run this one, so you get the standard deviation figure. I gave you the example that what is the standard deviation is, that is the average value that each member differs from the mean value. And similarly we can get the array b and their standard deviation. You run this one and you get the error. So you see here we cannot directly, because we have mentioned here spelled it wrongly. So keeping the spelling mistakes, so this is how we find the standard deviation for the second matrix. Similarly we can apply this operation axis wise as we have done earlier. Clear? And similarly along the different axis, run this one. So students, today we have learned how to apply this statistical function: minimum, maximum, sum, mean and standard deviation. So hope you have found the today's session quite fruitful. So at the end of the session, I thank you all for attending the session. Thank you very much.